So we're carrying on with the lecture and discussion about univariate statistics, data analytics. And what we'll do is just spend a little bit of time talking about, very short time, talking about plotting data visualization. And so first and foremost, it is a challenge to work with spatial data, to summarize, to visually inspect spatial data. It is sometimes kind of difficult. And so one of my favorite ways to look at spatial data is what we would call raw data postings or location maps. Now, the thing I like about raw data postings or location maps is the fact that there's no spatial bias whatsoever. You're simply showing the data values at the data locations. You're not saying anything about your preconceived ideas or your model of what you think is going on between your data locations. That's why we say that there's no bias in doing that. There's no model. There's no interpolation model at locations that you have not sampled. Also, it's very practical to do in 2 dimensions. I have this example here. It's a data set I've used with my students. It's a 2-dimensional data set, so it suggests that we're working with a single unit, or maybe we've done some type of vertical averaging over multiple units, but we have just a 2-dimensional data set. Often it's impractical to post or look at data in a static manner in the case of 3-dimensional data. If we had 3-dimensional data and the wells were vertical or slightly deviated, all of these circles would be on top of each other, and we'd be biased by what circle happened to be on the very top, depending which way we're looking at the data set. Much more useful when we are dynamically looking at the data, in which case we have it loaded up into some type of modeling package. There are methods in Python to look at 3-dimensional data, but of course we could be using more of the commercial type software where we can scan through and look at the data very effectively. Then it's more practical to look at display of raw postings or location maps. Now, let's take an example right here, a static image of a 3-dimensional data set being viewed with raw postings. And this is not even that bad, because you can see it's not even strings of data, it's just data at different locations in a 3-dimensional space. And looking at them, looking at multiple different variables and so forth can become very difficult. And so I would recommend raw postings in 3D more from the standpoint if you're able to zoom out, zoom in, you're able to move around, pan around through the image, change the location you're viewing from, then it can be, of course, much more diagnostic, much more useful than an image like this, which is really hard to understand or to share with others. And so if you look at the original book, Introduction to Geostatistics by Ed Isaacs and Mohan Srivastava, a really great book I recommend, of course. They have this example right here where they took a contaminant concentration sampled over locations and they applied what they call an indicator transform. And what the indicator transform does, it is a probability coding of the data. What's the probability the values are less than or equal to a threshold? And it's 1 if the data value is below the threshold, it's 0 otherwise. And so in this case, all the white circles are the locations that are less than the threshold. Those are the ones. The filled circles are the zeros. They're greater than the threshold. And so as you go across from a threshold of 0.56 parts per million to 0.8, 1.3 to 1.88, you see all the circles start to systematically turn into hollow circles or empty circles. More values are less than those thresholds. This is a very powerful way to look at data because those thresholds might be significantly important to us. Specifically, they might be thresholds related to some type of economic, in this case, maybe related to a criteria around environmental standards. What's the allowable contamination within a soil of different types of metals if we're doing some type of study of contamination. And so that's another thing to consider is we can apply transformations to our data so that when we visualize them, we start to see things, we start to see different patterns. I don't talk about it here, but even color bars. There's much you can do with color bars to be able to more clearly see features. Now, of course, there's so many different ways to show data. And so I went to Spotfire's website and I looked at a variety of different documentations, example workflows, and they have all kinds of wonderful ways that you can visualize data. The power with Spotfire, of course, is that you have a lot of fast filtering methodologies where you can filter large multivariate data sets And that's very good with multivariate display. You can change the colors, you can change the sizes, the shapes of the dots when you do raw postings. It's very powerful. Now, of course, within Python, there's matplotlib, there's matplotlib, I should say. There's also ggplot2, and there's seaborn, and there's all kinds of other methods that are developed to be able to display data, to display spatial data, to be able to see patterns within models and so forth. And so I put some interesting examples right here. Radar plots shown right here. Here we have a varogram map that's shown here, which is actually really, really nice, where you can see it contoured up based on spatial continuity directions. Spatial contouring shown here, so you can identify reservoir trends looking in a specific direction, plan view or vertical view. And so the ability to display data is very important to discover and to learn from our data sets. When we move from raw postings to all these other types of displays, we're assuming models, we're assuming smooth interpolation and so forth. And so there's assumptions that go in. Now, of course, we could think about advanced way to display and work with data. I don't know if any of you have experienced this. I had a great opportunity when I visited Baker Hughes, a GE company over in Florence at the research center. And I got to go into a virtual type of environment and manipulate large turbines and make repairs on turbines using tools. And it was a really amazing experience. Thank you very much to Baker Hughes. I did that while I was teaching there. It was very awesome. And so things like this, where you can fly around the subsurface, you can interpret the data, you can check the model, you can interact with the model. That's very cool when you're able to real-time edit a subsurface model. That's very powerful. Of course, the ultimate would be if you can real-time edit the model and watch the impact on subsurface flow. That would be extremely, extremely powerful. Now, what I'm going to do right now is have a very short workflow where I'll demonstrate some very basics of displaying data within Python. I will record that in a separate video, and you can load that up, work with the file. The file is right here if you want to get that ready, get that spooled up and get ready to work together on the next video. So I hope that this was helpful. It was a very short discussion. You'll note that I didn't go too deep into the whole spatial displays. And the purpose for the subsurface course, we will use a two-dimensional data set. We will work through all the subsurface steps, but we keep the display challenge relatively simple. That's because I have great respect for all of the kind of technical aspects of display and recognize the fact that we could spend an entire term talking about how to do ggplot2, getting into a lot of details about different types of plotting methodologies and how to optimize our visualization. And there's a lot of people who are deep into the scientific communications field who are concerned with how do we best display and show data. I will confess that's not my expertise. I'm an interested consumer of those products, but I will not go into any greater depth around that. As we move along, though, we will always have the challenge of how do we best communicate spatial information and uncertainty in an efficient manner that can be understood by our management and those who are making decisions going forward. And that will be our challenge as we move through the projects. Even at this point, I've seen teams who have done a really nice job of presenting their projects with really novel displays. And so I will be very happy to see that as we move along. And I'll share that with people who are interested in what's going on in the course. All right, I'll stop there. And I will have a walkthrough of basic display in Python using Jupyter Notebook right away here. Well, for you, immediately, just switch videos. It's in the next video. And so once again, I'm Michael Perch. I'm an associate professor at the University of Texas at Austin. And I am also the Geostats guy on Twitter, Geostats guy on GitHub. I am also, my lecture series here on YouTube is Geostats Guy Lectures. And I'm always happy to discuss. If you work with a group, an organization, and you're interested in someone to come teach or train, I do a lot of that. I travel around and teach inside of a lot of different companies. And so that's part of my role. If you're interested in supporting students, hey, let's talk. Let's do research together. We have great students at University of Texas. All right, I hope this was helpful. Take care.